What else you want me to say? Listen, ladies and gentlemen, you gotta try the rugs. This is what the hug is talking about. Hulkamania.
So in my last lesson, I showed you how simple the syntax for inheritance is. So this time, why is that important? And the core of object-oriented design is inheritance. So I want to give you an example of why. Because a lot of times in these interviews, you know, I get tied up in describing like why instead of just giving them the dictionary definition. And so I'm going to repeat those definitions again and then show you an example of why inheritance is useful and why it's so important to the core of object-oriented programming. So inheritance is the ability to create a class that inherits attributes and behavior from an existing class. Somebody asks you about inheritance, just give them that answer. I always mess up on that because I start explaining things. And just straight answer, next. Okay, so here we are. And I've made some changes to the code since we last started here with video 1. And I kind of went through inheritance and explained what was going on there. So I focused mainly on the syntax and not the showing how useful it is. So I'm just going to do a quick recap here now. We're going to go to our orc class, take a quick glance at our elf class, and you can see there's no code in any of those classes at this moment, okay? What they do, elf inherits from creature, and orc also inherits from creature. The creature is considered the base class. So what I've done here is I've created a life property, also a name property, type. I created this combat experience. I want, even though some cards start off weak, if you put them into a lot of combat, I want them to get stronger. And so this combat experience is how a weak creature gets stronger because you're constantly putting that card back into battle over and over again, and they gain however amount of points. But anyway, that's the thinking there. Creatures have attack power, and they have a weapon attack power. So if you give this card or creature a weapon, this is what it's going to affect. It's going to increase this attack power. And both of these powers together are going to equal the combat power, including a boost based on how much experience they have in combat. Same concept here with block. That's your block power. But if you give a shield, I have weapon, but a shield or something, this increases your block power. So the ability to absorb hits. In order for a creature to lose life points, the attack power has to exceed the block power, and the difference actually deducts from the life. So 2/1/1 creatures are not going to hurt each other. They're just attacking. And that attack is represented by this method, the attack method. And it's very simple. You have your weapon attack power added to your attack power that gives you a total attack power, and then you want to see, do you have any combat experience, and multiply that by whatever your attack power, total attack power is, and then add it into your attack power and then assign it to the final value of your, so that's that whole calculation. I'm sure I could have written that better than that, but I was trying to be quick. And I really wanted to spell it out what's going on. And it's going to then return your total attack power. And the same concept here as far as block is concerned. Weapon block, give you total block, and if you have combat experience, you become better at blocking. And so the notion here is all this stuff is certain values are going to be stored in a database, and when your card is loaded into the whole game space, it's going to come already pre-populated with this power, so that as this card goes on throughout the history of its combat, it can get stronger and stronger, and that's the concept there. And it gives you, I'm assuming it's going to give you strategic things that, hey, this creature looks weak, but yet it's a little bit stronger than you would think. Anyway, and so we'll move over to the program where we're going to really talk about code reuse, and that is one of the benefits of inheritance. Code reuse, tons of things. Inheritance is at the core of object-oriented programming. I mean, you can get to a state in object-oriented programming where you don't even have to write loops and if statements, and we won't get into that, but this is just at the very basic, the starter's kit to the galaxy of inheritance. So, what we have here is using object initialization syntax here. I'm giving the elf, player 1, an attack power of 1, a block power of 1, a life of 10. I gave it the name I Sam, and I'm gonna make him Don, from Don in Love and Hip Hop Chicago. No, not Love and Hip Hop Chicago, Black Ink Chicago. So we'll name him Don. Anyway, and their attack power is 1, the block power is 1, life is 10. And I kind of briefly said, if these two creatures attack each other, their life total should remain unaffected. And so, instead of having just player 1 here, we'll use a string interpolation. Yeah, say that 100 times. And we're going to have player 1, and we're going to show his name in this particular example. So now player 1, I Sam, life total equals life point, and we'll return it as a string. And then we'll just grab this here. And I'll be player 2. So, briefly now, I just want to go to, you see how I just made that code change? Because I know that player 1 and player 2 inherit from the same class. Therefore, I knew this name property would be good here and in player 2, even though those values are different. These are simple but clear definitions of how inheritance even allow you to code faster, because we know that because orcs also inherit from creature and elves also inherit, we're guaranteed that this name property is going to be here just because we understand this relationship. You don't try to force object-oriented programming into your code. You just take your time and analyze it. It will make sense by itself. It'll just like, oh, these are sheer, okay, we're gonna do that. And that's just thinking with an object-oriented mind, especially at the very beginning stages, because this is gonna be a question in every interview. This is the job, so there we have it. Now, this method here that I created, this is called the fight method. I should name it the fight club method. There's only one rule to Fight Club. And so let's jump into the Fight Club. The fight method. And this is going to talk about this is where we're going to flush out our attack, our combat mechanics. First thing we do is call this method and say, did this return a value greater than our block? That's the only time we need to evaluate, because only the difference is applied in our attack. If that's the case, then we subtract the attack from the block, and whatever's remaining, the life will substitute that from there. So when player 1 is strong, attack is strong enough to get past players 2 attack, then we're going to go and affect players 2 alive. And at the same time, we're going to have player 2 attack player 1, do the same type of evaluation, and then the difference is taken away from the life and then given the new value of the player's life. So a 1/1 creature won't hurt anything if it's attacking another 1/1 creature. And in our case, we created right here 1/1 attack, 1 attack power, 1 block power, and any of you guys who've done Magic the Gathering, all of this simply makes sense. And oh, here we go. We're gonna we're gonna run it. Hopefully that'll all work. And let me slide this into view. So there we have it. We inherit that functionality, gave it to 2 classes, and we took the name and included it in the string, and none of the life power has been taken away, because that is the game mechanics. That's how our combat is going to work from here on in, at the very basic design of this thing. Now, let's ratchet it up. Who do we want to win, an orc or an elf? Orc, elf. Okay, this time we're gonna give elf some muscle here. So, if this is right, if I didn't screw up the rudimentary math down here, someone's life total is going to be decreased by 1. And is that what's going to happen? Yes, that should be what happens. We're gonna run it again. I'm gonna have to slide that into view. And there we have it. Sam the elf was defeated. And we could go ahead and play around some more. Let's go ahead and add the type. Let's go and say, all right, your type, you are going to be an elf. An elf, I don't know, let's let's call him an elf level 1. It's late for me, so I'm not gonna be that creative. Control V. And this is gonna be an orc, level, I don't know, 3. And when you're a level 3 elf, you have like a block of 2 and an attack of 3. And I'm sorry, we're gonna let the elves get it today. But in my next video, we will do something about that. And so we're gonna move player 1, and we're just gonna put the name for now. Whoops, yep. Life total. And then we're gonna say what his type is. And then use again the new string interpolation. Let's go play 1. Whoops, did I say something wrong? And of course we'll do this again in the interest of speed, and we'll make sure we do player 2. And the orc card is just doing its business right now. Kaboom! Oh my goodness. So there we have it. This example was just showing code reuse, and I absolutely slipped something else in there. I'm going to show you something, and we'll get to that in the next video. Notice that both of these classes are elf class, but in the fight method, I have its method signature as creatures. When we get back, we will be talking about polymorphism, and the inheritance world is going to grow. So I hope this was fun and entertaining, but most of this was just daydreaming of what would be the best way to go about it. And creatures inherit is the base class, and then we inherit all our powers, and we create our different types of creatures. If we created a dragon right now, we can take that as a creature, and then as we move into polymorphism, we will say, hey, how come this worked? Why did this work? This isn't a creature class that you passed in here. You passed in an actual elf class. And so we'll get into that next. All right, thank you very much. And I hope this nailed, like this is like the Captain Obvious video. Nail it, you got it, you'll never forget it. Thank you very much. Goodbye. Hey guys, this is my YouTube channel. It's named Nerd House Geeks. Show me some love. My last lesson was tuples. I was asked a question by a colleague about stuff, so come on through, subscribe to my channel. This video right now is dealing with the C# inheritance, so this is the second video we've worked on. But come and check it out. I have Learning to Speak C# where I focus mainly on the language. My advice for surviving in IT. And then earlier this year, I went to the Phoenix Comic Fest. And thank you very much. Thanks for watching my video. Like and subscribe to my channel if you want to. I appreciate it. And I'll share as much as I can about surviving in IT.